Hi, I'm Mingyuan from Hong Kong UPass Research Pool. Virus infection remains a serious issue in public health. Viruses can only survive in the infected cell because they are tiny and contain a limited number of indispensable genes to start their replication. To get the job done, viruses take advantage of cellular factors to assist them to produce new viruses, deliver them out, and infect other cells. In my study, I focus on dengue virus. Most people who are infected by dengue virus through a mosquito bite only exhibit mild flu-like symptoms. They can quickly recover without any complications. However, in some cases, dengue virus causes a severe illness that is responsible for 20,000 to 15,000 annual deaths, and there is no treatment available at the moment. Our studies demonstrate that a receptor molecule called K receptor can facilitate the transport of newly formed dengue particles from the endoplasmic reticulum, shortly named ER, where those virus particles are assembled, to the Golgi apparatus, shortly named Golgi, which is the second station of so-called secret pathway, the main street that is used to export content from inside to the outside of the cells. Let me expand more about the K receptor. In cells, K receptor function as a short bus, cycling between two intercellular bus stations, the ER and the Golgi. Their main function is to make sure that central proteins never leave the cell and remain in the ER. Therefore, the K receptor short bus travels empty to the Golgi, where they grab those proteins and bring them back to the ER. Our data show that dengue viruses use this situation by directly binding to K receptor to initiate the transport from the ER to Golgi. For example, depletion of K receptor significantly reduces the secretion of dengue viruses. In addition, I have identified one of various drive proteins on dengue particles is recognized and binds to K receptor. Blocking this interaction through genetic manipulations has been observed to efficiently inhibit dengue virus transport into the Golgi. This work provides an answer to a lingering question: how does a virus that assembles inside the cell find its way out of it? According to our findings, dengue virus has solved the problem by hooking to K receptor and taking a free ride out of the ER. In normal cells, K receptor travel with no passenger to the Golgi when they found the targets and bring them back to the ER. Occupying an empty receptor and jumping off it before it starts its own physiological function is clever and very effective. Dengue virus does nothing to disrupt any cellular function for this part of its intercellular transport. Since recently published studies have suggested that K receptor may function as a signal transduction molecule. They may trigger and regulate the intercellular transport not only between the ER and the Golgi, but also the Golgi to cell membrane transport, which is the further step for dengue virus release. This opens the possibility that K receptor may play a more important role in dengue release by orchestrating its transport and release through multiple checkpoints. Further study will verify how K receptor triggers the release of dengue viruses and whether we can take advantage of this knowledge to interfere with the dengue infections.